Hello, my fellow American engineers. I hope we are doing fantastic. I am here with another amazing video today. And this video, it's a great video. I think it's one of my best videos. It's going to be on Mohr circles and stress elements. Let me tell you something. This is a big topic in engineering. I've done it multiple times on multiple classes. I'm telling you. I've done it in machine design. I've done it in stress and analysis, and I've done it in strength of materials. These are all very important classes. Now, what we're going to be doing is doing a review of stressful elements. I expect my Americans to know what they are and how to use them, but just in case you don't, we're going to go over them today. And then we're going to do an example of using the Mohr circle with the values of a stress element. This will be very easy. I'm going to go through it step by step with you so you have no issues whatsoever. And many people can do this. It's not hard at all. The only person that probably can't is Sleepy Joe. He's very incapable. He couldn't hold the pen. Just unlike the auto pen, he held that one just fine, but he couldn't hold a regular one. Alright, let's begin with our stress element review. It's quite easy. What we're going to do is we're looking at this square right here, okay? And I have multiple labels already picked out for you. I have the sigma x, sigma y, and the tau xy. These are all very important. You really need to know what they are and how to use them. What we're gonna do now is we're gonna be looking at. Let's look at the axes first. You see here we have the x and the y axes. These are pretty normal standards in your axial coordinate systems. We're gonna look at the stress values now. As you can see, we have sigma x going outwards and sigma y going outwards. With a stress element, that means that these values would be positive. That's a good thing. Positive values are nice and easy. If we had a stress element, let's draw a stress element with no arrows on it. Let's do it. Stress element. If we had values that were negative, they would go in. So if we had a sigma y that was negative 10 megapascals, the arrow would go down instead of in. The same thing can be said for the sigma x value. If it goes to the left instead of the right, that's a negative value. Very easy, very easy. Let's talk about tau xy now. The variable tau xy is based on the face, which is the first variable, and then the direction, the second. We have tau xy here. This is our x face. Easy, very easy. And since we're having a positive tau xy, that means we are going x face, positive y. Positive y is up, so that means we go up. Then you have to meet the corner. You have to. That's very important. You must meet the corner. There you go. And now you just do the opposite on the other side. Bink, bonk. Just like the YMCA. Very easy, very catchy, very simple. Now, let's go over how to actually draw one with numbers. I know this is scary, but this should be real easy for us. Let's read the fantastic question I created for you guys. Use the following values to fill out the stress element. Alright, let's see what we have. We have a sigma x negative 45 megapascals. I think first things first, we must define our coordinate system. That should be step number one when looking at stress elements. What's the coordinate system? Is it normal or is it non-American? We're making this an American one, so we're doing it right. Let's set it up. We have a positive y-axis, positive x-axis. That's easy. All right. We have a negative 45 megapascals. That's a big number, but that's not big enough for me. I can handle it. We have negative. What does that mean? That means we're going into the page, into the square. And we're going to write it just like that. And that is the same thing on the other side. It's the opposite. As you know, this side would be the negative x-axis. Negative, negative, that's positive. So we're heading it to the right, which is just fine. That's correct. That's good. You're doing good. All right, now let's head to the sigma y value. Sorry, sigma y. Here we go. 35. Easy. What is that? That's a positive value. All right, let's go. sigma y, here we go. Whomp equals, what did we say? 35 megapascals. That's just fine. And we're going to do the same thing on the bottom. Very easy. Now let's look at the tau xy. We have 42 megapascals. We have x and y, and it's positive. What does that mean for us? X face, y is positive, so we're going to go up. And we're going to meet at the corner. And we're going to say tau xy is equal to 42 megapascals. That was very easy, wasn't it? Even Sleepy Joe, he could probably do it. I think he could. He has the potential. I really think if he tried hard enough and he stopped eating so much ice cream, he could do it. All right, that's it. That's how we deal with stress elements. Now let's do a Mohr circle. If you don't know what Mohr circle is, it tells you multiple things about the thing about a element. It tells you stresses. Let me tell you stresses. I know lots of stresses. I'm in lots of stress right now. You can find your plane stresses. You can find your shear stresses, your principal stresses. All of this stuff is great for Mohr circle. If you need to learn more about that, instead of how to do it, please do find another video. Or if you would like me to make a video that's more descriptive instead of example based, I'd be happy to. Just let me know down in the comments. So let's read this question that I created. Another great question. Mohr circle example 1. We're given sigma x is 16 kpsi, sigma y is 9 kpsi, and tau xy, it is 5 kpsi. These are great numbers. I like these numbers. They shouldn't be hard to deal with. And it's telling us find the principal stresses and the principal shear stresses and the max shear stress. This sounds like a lot of work, but let me tell you, this is real easy. Now, there is one thing about the Mohr circle that you should know. It is very easy to understand, but you must make sure you know it. All right, let's do it. The setup of the Mohr circle, we have tau and we have sigma, right? That is easy enough to say as it is. But what could be complicated is that the y-axis is actually the negative tau axis. And what we consider negative in engineering, what do we consider negative? We consider the clockwise direction negative. So this way versus this way we consider negative, this way we consider positive, right? That's a very nice way to do it. I love that. So what are we going to say? We're going to say tau clockwise, and we're going to go down here and we're going to say tau counterclockwise. Very easy. All right, let's keep her going. The sigma axis, that stays the same. Positive to the right, negative to the left. Very easy. I promise. This will not be hard. All right. The first thing to do when doing Mohr circle is finding the center of your circle and the radius. That is a very huge, very tremendous thing to do. Let me tell you why. If you don't know these things, you won't get a circle. You'll get some random shape, probably a triangle. Let me tell you, triangles are not nice. So many things you have to do to prove that they're triangles. Why? Such a difficult shape. But let me tell you, circles, they're very nice to work with. Very easy. So many wonderful equations. And let me give you the equations you need to calculate the center and radius. Let's go off here to the right. Let me tell you the center equation used for Mohr circle. You might know this, and if you do, you're great at this. It is sigma x plus sigma y over 2 comma 0. These problems are easy. You'll always be at 0 on the sigma axis when looking at the tau version of the number. This value will always be 0. You cannot be on the sigma axis when doing Mohr circle. You must be. If you are not, you've already done something wrong. Or your professor has. And let me tell you, if your professor does that, let me know. They may not be an American professor. We'll figure it out. That's our equation. Now let's tell you what the radius equation is. The radius for Mohr circle is just as easy. We're going to take the square root, and we're going to take the square root of. We're going to do sigma x minus, that's very important, sigma y over 2. Square that, that's important. And then we're going to add the tau xy value squared. That's it. That's the equation. I want you to notice this negative value right here. That is huge. If you have a negative sigma y in your question, you must make sure that that becomes positive, because a negative times a negative is equal to a positive, right? So a negative 16 is equal to positive 16. You must know this. The value you put in for tau xy, that is not as important, because any value squared is going to be equal to any value squared, negative or positive. So it doesn't matter. All right, there are your equations. Let's keep her going. We're now going to move to calculating the values here. So let's do it. What was our sigma x? We said it was 16. 16 plus what? I don't know. What was it? It was 9. Good job. Very nice. Thank you for remembering. That's very good. I hope you have your calculators handy. If you don't, you should get one. Calculators are going to use them very lots. Now, if you have a graphing, that is just fine. You could calculate Mohr circle on graphing, but we're going to do the American way, by hand, entering numbers. So let's do it. 16 plus 9 divided by 2. What are we getting? 12.5. Positive. That's important. What is our units? We just carry the units. We have kpsi. That's a good thing. Very good. And now let's do the radius. We're going to do the square root of sigma x, we said was 16, minus our positive y value, so it stays a minus, is 9 divided by 2 squared, plus, what's our tau xy value? It is 5 kpsi. Now let's tell you something. This is positive, so what does that mean? That means it's in the counterclockwise direction. You can note that, or if you're very smart, you're truly American, you don't have to. I'm noting it for all my non-American friends out there that are learning to be American engineers. All right, let's put that value in. We said 5, so we're going to do 5 n squared, and we're going to enter that into our calculator. If it's not American made, it's not the best, but I'll take what I can get. You are very hard. You're trying very hard here, so that's okay. I've got a value of 6.1 kpsi, and that's correct. That's a good value. It's one of the better values here. I'll tell you, these are very nice values to work with. If you are afraid, don't be afraid. We're going to work through this together. All right, we have the 2 biggest values we need. Let's start plotting. I know this is the scary part. Everybody says, Donald, I'm not good at plotting, not nearly as good as plotting as you. What can I do? And I say, just count. Use your fingers, use your numbers, use what you must, but count. This is the easiest thing I can tell you. But let's do this. The way I have this set up, it's in terms of 2. Every line, every dash is in terms of 2. So that's what we're going to do. We're going to count. We're going to go 2, 4, 6, 8, 10, 12. Stop that right in the middle. This is our center point. This is 12.5, comma 0. Very nice. You guys are doing wonderful work. Very proud of you. Now, we have a radius. What does that mean for us? The radius, that is half the circle, right? So we must go to the left the radius value and do the right the radius value. Very easy. Take that calculator of yours. Do 12.5 plus 6.1. What do we get? 18.6. Very good value. Very easy. This is 14. This is 16. This is 18. We're going to go a little bit to the right here. Right here. We're going to say this is 18.6. And we're going to go to the left, 6.1. So 12.5 minus 6.1. What do we get? We get 6.4. I'm going to count from the left. 2, 4, 6, and a little bit to that is 6.4. See how easy that was? That was easy. I'll tell you, Mohr circle is very easy once you do it. Don't be afraid of it. It looks hard. It looks impossible, but it's not. Now we gotta draw our circle. What I'm gonna do is I'm gonna use the drawing tool, because why make things harder for yourself if you have something to make it easier? But not the auto pen. That doesn't count. I'm gonna auto draw a circle. I'm gonna move it here. I'm gonna touch the side with one point and touch the other side with another point. And it looks pretty good. Looks pretty lined up to me. I like this. This is a very nice circle. I can say nobody can do this better than me. I draw the best circles, and that's why I'm your president. Really, I was voted for this. All right, let's keep her going. We're doing great things. Now what we're gonna do is the principal stresses that it asked us. There are 3 of them, sigma 1, 2, and 3. That's very important. You should remember that. Principal stresses, there are 3 of them, sigma 1, sigma 2, and sigma 3. One of these is gonna be 0, and that is the furthest value to the left. So let me tell you, if we had a chart and our circle did this, this would be our sigma 3, this would be sigma 2, and this would be sigma 1. There's our 0 value. But let's look at our example again. Let's see. Let's see. We don't have a value over there, right? We don't even have one at 0. That's very weird. That's not good. But let's make it good. Let's fix that problem. We have our sigma 1 value already. It's already told to us. It's right here. Sigma 1 is right here. Very easy. Already given. We calculated it. What about sigma 2? We did do that one. You're correct. It is also calculated. It is right here. Easy. So that means our sigma 3 must be 0. And where is 0? There's 0. Easy stuff. I'm telling you. You're very good at this. You're going to be one of our greatest engineers. So let's draw another circle. I'm going to do it in pink because I love pink. It's a very nice color. I have dated lots of women who have made very nice dresses and worn very nice dresses in pink. I'll tell you, they're very nice. So let's make the circle fit what we need it. Very good. Now what I like to do is there are multiple, and I'm telling you there are 3 different principal shear stresses for 3D. Now what we need is 3 circles, 3 stresses, 3 circles. That's good. That's what we need. So let's do it. I'm gonna do brown. I don't know why I like brown. The color is just so appealing to me. Let's move it over. Let's make it big. This is going to be our big circle. We're going to stick it at the 1 point, sigma 3, which is our 0 value, and it's going to touch sigma 1. And there you have it. There's your Mohr circle drawing done. That's it. That's all you have to do. Super easy. I told you. If I can do this, you can do it. But Joe Biden, he might not be able to. All right, let's continue. It said principal stresses, principal shear stresses, and max shear stress. So what did I already say? We can find our principal stresses. We already did that. That is our sigma 1, our sigma 2, and 3, which is our center plus radius, center minus radius, and 0. So sigma 3, that's correct. It's 0 kpsi. Sigma 2, what did we say sigma 2 was? I don't know. You tell me. No, that's correct. 6.4 kpsi. Good job. And what's the third value? Or our first sigma? 18.6. I love this. You are doing great. And that's part of the answer already. Easy. Alright, now it said, hey, let's calculate the tau values that we need. I said, very easy. I can do that. So we're going to calculate 3 tau values. And here's where they come from. They are the radiuses of every circle on our Mohr circle. Very nice. Alright, let's see. This is sigma 1 to sigma 2. So this is tau 1, 2. This is sigma 1 to sigma 3. So this is tau 1, 3. And this is sigma 2 to sigma 3. So this is tau 2, 3. Smaller to bigger. Very easy, very easy. So they want us to calculate each of these values. That's fine. That's easy. I'll give you the equations. You'll have these. Let's go down here and look. Let's start with the big one. 1, 2. That's the main circle that we drew. Let's look. It's sigma 1 minus sigma 2 over 2. This is important. Please make sure you know. Don't get confused now. We said tau 1, 2. That's our main circle. That's the one with the biggest information that our element is based off of. So don't forget that. Alright, let's go. Sigma 1 minus sigma 2. Let's do this calculation. Please do it on your calculator. What is the value you get? 6.1. I love this. That's a good value. Let's just double check. 12.5 minus, what was sigma 2? Sorry, 18.6 minus sigma 2, which was 6.4. Divide that by 2. 6.1. We were correct. Now this value, it looks a little familiar, doesn't it? It looks very familiar. It seems like we've calculated this before. That's correct. If you guessed, you guessed correct. We've calculated this value. It's our radius. That's very important because that also means we've also answered another question. What is our tau max? Tau max, let me tell you. It's a very easy equation. But you can also say tau max is equal to radius value. But if you're unsure and you don't want to do that, here's the equation you can use. You're going to do this. Now, this equation, it looks a little familiar again, doesn't it? That's right, it's just our radius equation. So that's why if you've calculated your radius, you've already done tau max. That's why it's so easy. Mohr circle, it just gets easier. Good job, everybody. 6.1 kpsi. You've done good work. We're almost there. And now we're going to go calculate all of the rest of our d tau values. We're going to go to tau 2.3, and we're going to go to tau 1.3. All right, let's do these equations. Sigma 2 minus sigma 3 over 2 and sigma 1 minus sigma 3 over 2. Very easy. And plugging those in, you should be getting 3.2 kpsi and 9.5. Now, look at your values, look at what you've beautifully calculated, and make sure that makes sense. Let's check. Sigma 1 or tau 1.3 is our biggest radius, so it's our biggest value at 9.5 kpsi. It's as big as the wall that I've been building and have built. It's a glorious wall, and it's a glorious number. That's right. Tau 2.3 is our smallest value, and it's at the smallest circle. That makes sense. That's good. And tau 1.2 is the radius we've already calculated, and it concurs with what we've already done. That's good. That's very good. So you've done it. You've calculated what we've asked you to do. The tau values, the tau max value, and the principal stresses. You've done good. Very nice job, everybody. This is it. This was all I wanted to tell you. If you really need to know more, there are other things we could teach you. But this is a good start. This is what I wanted to give you guys. Just remember, negative values. If you were to be given a question that was tau xy is equal to negative 10 kpsi, let's say, and you were like, Donald, how do I deal with this? I'll tell you, let me tell you. That's counterclockwise, right? No, you're wrong. That's clockwise. That's correct. That's a good one. We said clockwise. That would mean if you were to plot it, it would be in this region. That's the clockwise, the bad region, where the illegals hang out. But since we're not doing that, you go over to your equations and you say, Donald, what do I do here? And I said, remember, it doesn't matter here. It's the same thing. And then I said, Donald, what about down here? And I said, again, it doesn't matter. It's the same thing. Now, if you're looking to find a theta value or phi value from theta to the principal axis, that principal axis, what is the principal axis? I think I said it earlier. That's the sigma axis. There is an equation, and I can give that equation to you. That equation is tan of 2 phi beta. That is a great start. I love saying these tan of 2 phi beta. I love saying words. I think I'm very good at saying words. And it's going to be equal to 2 tau xy over sigma x minus sigma y. Very easy stuff. Now, this is very nice. Remember, what is this 2 here for? Do you know why this 2 is here? That's okay. I can tell you. The difference between Mohr circle and reality, there's a difference, believe it. That the values in Mohr circle are double what they are in reality. So if you were to get an angle right here of 30 degrees, and then you came back out and you said, let me do the plot, this would be 15 degrees. So remember, you must divide by 2 to get out of Mohr circle and multiply by 2 to get in Mohr circle. All right, let's keep going. Let's do it. We're here. Let's calculate phi. Let's calculate it. All right, so we have 2 tau. 2 times 5 because we had a positive 5, right? Remember, it gave us positive 5 counterclockwise, so we're going to keep it positive. But remember, if you had the negative value, it would be 2 times negative 10. And we're going to divide it by sigma x minus sigma y. 16 minus 9. Let's do both. We're going to do both equations so you can really understand what I'm trying to point out. So let's calculate this. Get your calculator. You're going to do the calculations. 2 times 5, 16 minus 9. you get 10 sevenths. You're going to take the inverse. That's right, the inverse tangent of that value. And what did you get? I got 55.0707 degrees. But remember, we have that pesky 2. Let's divide it. And you get 27.50. That means that theta p is equal to 27.50 counterclockwise. Remember, positive. And now let's do the other one. 2 times negative 10. What is that? That's negative 20. That's a good number. That's a nice number. I like it. And 16 minus 9. I've got negative 20 over 7. That's good. Now we're going to take the inverse tangent of that. I've got negative 70.709 degrees. That's good. And then we're going to, again, divide it by 2 because that pesky 2, he just doesn't go away. The Democrats, that's that pesky 2. They just don't stop talking to me. They say, Donald, what are you doing? I'm saying I'm making America great again. All right. I've got negative 35.35 degrees. That's good. But that's not the best way to write it. Let's write it like this. 35.35. We had it negative, right? That was a negative value. So we're going to say degrees clockwise. Remember, clockwise is negative, so this would be the better way to write it. If you kept it like this, that's fine. But it wouldn't be quite correct. It wouldn't be quite right. The American way is to change it and make it clockwise. And that's all you need to know for Mohr circle, ladies and gentlemen. This is it. If you really need more help, please let me know. You should be able to do many, many examples with this explanation. It shouldn't be hard. You are very capable citizens. I know you are. Please, please try more. Please do more examples. I hope you do well. And if you don't do well, you can blame China because they could have made those examples. If you do the American made examples, you'll do just fine. Thank you.